So in today's lesson, we're going to look at factoring polynomials. You already know how to factor a trinomial, so we're just going to build upon that. So I'm actually going to skip this first slide and go back to it. But when you had your summer packet coming into Algebra 2, you did factoring. We reviewed it in the very beginning of September, and I gave you this kind of flow chart. So the main idea is always look for a GCF, and then we have these four ways. We have our difference of two squares, we have our diamond shortcut method, and we have our grouping, and then obviously the combination of these two. So those are all ways to factor quadratics. We're going to build upon that. We're going to learn one more way with cubics, and then all those larger polynomials, our fourth, fifth, sixth, seventh degree, and so forth and so on, is all a combination of these. So we might have to find a GCF first, or we might have to do multiple ways of factoring. Like we might have to do the difference of two squares twice, or maybe we're going to group it and then do the difference of two squares. We're just going to be building upon everything in this flowchart pretty much. Okay, so actually let's go back to this sets of graphs. We can use our graphs to help us with factoring polynomials as well. If you remember our zero product property, it tells me that if I have multiple things multiply together to equal 0, one of them has to be 0. And I can use that fact to help me find the roots of an equation by looking at the graph. The roots are your zeros. So if I'm looking at, let's use blue. Question A, right? I have a root here, so that's at -1. I have one here at 0, and I have one here at +1. Knowing those roots, well, I know where they came from. A -1 came from an x plus 1. A 0, if you want to put it, is x plus 0. And a +1 is x minus 1. Remember, it comes from the opposites because you had to set equal to 0 to solve it. And this would be my factored form. Now this x plus 0, we tend to just write as x. So I just quickly factored that whole problem without really doing much work other than looking at a graph. Okay, and real quick, I'm just going to do C. We have a quadratic. Now we know how to factor that, right? We know factors of 4 that add to 5. But if you didn't, here's one, here's the other. So this one is at -4. This one is at -1. And those come from their opposites. So x plus 4 and x plus 1 equals 0. And again, we know that. We know that factors of 4 that equal 5 are 4 and 1. 4 times 1 is 4, and 4 plus 1 is 5. Okay, so we're going to be going through some of those other ones as well, but not the hardest thing to do given our graph and given our zeros, especially when they're whole numbers. Now, once they become non-whole numbers, it gets a little bit harder. But again, we're going to utilize all of this stuff to help us get through it. So these are just some basic polynomials to practice solving. We spent a whole day on reviewing how to solve by grouping, right, and GCFs over here. So I'm not going to go through these examples. Here's our new way of factoring. Sums and differences of two cubes. Let me move myself up here. So with your sum and differences of two cubes, they're done identically. The only thing that's different is obviously whether it's a addition or a subtraction. So just so you know, you're going to take the cube root of whatever you have, as long as they're perfect cubes. You take the cube root of your first term, you take the cube root of your second term. The roots of those are either added or subtracted, depending on the sign. And then the trinomial behind it is fully factored. You can never factor that trinomial any smaller. And it is the square of the first term, the square of the last term, and then the product of the two. Now, the way you remember it is these two signs will always be opposite. So if this is an addition, this first one's a minus. This is a minus, this one is an addition. You're always adding your square at the end though, because anytime you square a number, it's going to be positive anyway. Okay, so I have two examples here. X cubed plus 27. Well, the cube root of x cubed is x, so that's my a value. The cube root of 27 is 3. That's my b value. And then I can just fall in place where they belong in this formula. So it's x plus 3, the roots, x squared minus the product of the two, plus your b squared. And then I just cleaned it all up, simplified what I could, and rewrote that x times 3 as 3x. Same thing with my difference of two cubes. Cube root of x cubed is x. Cube root of 1 is 1. And again, I'm not using the signs here because the signs are built into the formula. So I'm not going to take the signs into play since they're already built in. Okay, take your roots, subtract them because that was the operation in the original problem. And then again, square your first, square your last, product of the two in the middle. Okay, so let's try one of these. Okay, so let's do this one over here. I have 27a cubed plus 8b cubed. So this is going to be my first term. I'm going to take the cube root of 27a cubed. Well, in that case, you just cube root each part. So the cube root of 27 is 3. Cube root of a cubed is a. So that is my first term. My second term, I'm going to take the 8b cubed and find the cube root of that. Cube root of 8 is 2. Cube root of b cubed is b. Okay, so now from here, I can group these together. I'm just going to move myself down here to get my completed factor. So we take each of those, 3a, sine of the original middle, plus 2b, times first term squared, so 3a squared, minus, so it's going to be opposite, the product of the two, so 3a times 2b, plus the last term squared. And then I'm going to clean it up. So this is 3a plus 2b. 3a squared is a 9a squared. You have to square both parts, just like I had a cube root both parts here. I have to square both parts. Minus 6ab, multiply. 3 times 2 is 6, a and b. And then plus 2b squared is a 4b squared. Remember, you're going to factor, you're going to square both of those terms. And this would be your factored parts. Okay, so again, when you go through this, make sure you cube root each part. And then it's a matter of just plugging it into those formulas. And if you need to rewrite those formulas each time to look at, then go for it. Okay. Let me clean this up. Now, what we're going to be getting into is building on our factorings. So like I said, we're going to look at the polynomial. If there's a GCF, you're going to take the GCF out and then see, well, what do you got left? Do I have a difference of squares? Do I have cubes? Do I have a trinomial that I can factor using my trinomial methods that I know how to do previously? Okay, and that's all this is. It's just you're going to be doing multiple ways of factoring. Okay, so I have two here. Don't let the 4th degrees or the 6th degrees scare you, right? Any even number, I know I can divide it by 2, so that would be considered a perfect square. So that 16x to the 4th is really 4x squared when I split it. And then it just so happens I can split it one more time. When I do the next one, factor out the GCF, which was a t cubed. And then when I did my grouping, I saw, well, I can do one more time. So I did GCF, I did grouping, and then I did difference of two squares. So again, these larger polynomials are just repeating smaller and smaller ways of factoring. So you don't just do factoring once and call it a day. You're going to have to factor it multiple times. And we'll go through all of these examples in class. And the last thing we're going to take a look at is this factor theorem. So your factor theorem is using our synthetic division. So with synthetic division, we'll review that in a moment, if you get a remainder of 0, then you know it's a factor. If you don't, then it's not a factor. And once you get that remainder of 0, you can continue factoring further. You just helped yourself get it a little bit smaller. And that's how using that graph that we did in the beginning, maybe one of them's a whole number and the other one's not. We'll use the whole number to help you get it smaller so you can factor the graph, you can factor the polynomial a little bit easier. Okay, and this is just 2 examples of them. So again, you need to find a k value. Your k value is you take your binomial, set it equal to 0, solve it. That goes on the outside. All of your coefficients, and if they're missing any, like down here, you put a 0 in. And then you drop the first term, multiply the outsides, bring it in, add it, repeat. So again, this is our synthetic division. When we do so, we look at the remainder. Remainder is 4. It's not 0. So that tells me this is not a factor of the problem. And if they're not asking you to factor it, if they're just asking you to determine if it's a factor, you just call it a day. You move along. You say it's not a factor. In example 6 is a little different. It says, show that it's a factor, and then factor it completely. So that's what we did. Found the k value of -3, did my synthetic division. I got a 0. Perfect. I know it's a factor. So that tells me x plus 3 is a factor, and then the remaining polynomial is my next factor. So this becomes x cubed. Remember, you decrease a level. So it was to the 4th, now it's a cube. And then you go through, the only thing left is a c value. So I got -1. And that ends up being a perfect cube that I could factor out further. I know this is kind of blocking it right now, but you'd be able to see it when you pull it up on your own. So we can use the synthetic division to help us factoring as long as we get a 0 as a remainder. Okay. And again, we're going to be going through a bunch of examples of those. And with this real life application, we're going to do it in class together. But what I want to bring up is we're going to use these graphs to help us. For instance, I can see this graph has a -1 root. I can see it has a 2 root. And then I don't know what that is. That's a decimal. But I know at least 2 of the factors that I can use to help me narrow it down when I do my synthetic division. So for instance, if I want to use that -1, then I have the -1 on the outside, and then I set up my synthetic division for -21, 9, and 34, and then I can go through that synthetic division. What should happen is I should get a 0 as a remainder, and then I would have another set of a trinomial or a polynomial that I can either try to do factoring on, or I could do another set of synthetic division because I already know another value. I know 2. So I could also repeat that if I'm struggling with the factoring. And again, we're going to do this one in class, so I'm not going to go through us on the video right now. Okay, so hopefully as you go through this and continue practicing, you'll get a better handle on our factoring of polynomials.